Hello, good people. Welcome to the next video. We're going to go ahead and put some of those ideas on paper. But just to recap and make sure that we're understanding what we're talking about. Remember, the derivative is finding the slope of the tangent line. So let's say I have a function like x squared. If I ask you to find this, the derivative of f at 1, I'm asking you to find the slope of the tangent line. And we're talking about the tangent line that sits right at 1. So let me make 1 here darker. And then I'm just going to skim that. We're talking about that slope. And I'm trying to figure out what is the slope of that line at x equals 1. And then when I ask you to find f prime of 2, I'm asking you to find the derivative at x equals 2. So we're looking for this. Let's see, something like this. And when I'm asking you to find f prime of negative 2, so this, I'm asking you to find the slope of the line at this point, of the tangent line at this point, right? So I'm drawing tangent lines, but the derivative is the slope of these lines that I'm drawing. So if I get that, take that away. So I'm looking for the slope of the green line. That would be f prime of negative 2. I'm looking for the slope of the blue line. That would be f prime of 1. I'm looking for the slope of this magenta purplish line. That would be f prime of 2. So now the question is, how do we do that? Well, in the previous class, we talked about how we could estimate. But using the formulas that we saw in the second video, we can create a limit that's going to find the actual slope of the line. So what I'm going to do is I'm going to pick one of these, and let's pick this one to find. I'm going to ask you to maybe come over here to the side. Excuse me. I'm a little fortunate because I can make this space a little bit bigger. I know you cannot. But we're going to find f prime of 2. And according to the formula, we can find f prime of 2 by taking a limit. We're going to take the limit as h approaches 0. Now, what does h represent? H represents, remember, the distance between the x coordinates of my 2 points. And what I'm going to do is I'm going to make that distance go to 0. So that means the points are going to get closer and closer to each other. So we're going to use the difference quotient, and it's going to look like this. Now, I'm going to subtract the outputs, and I'm going to subtract the inputs, except the distance or the difference in the inputs is h. And then my outputs, well, it depends, since I have 2, f of 2 is one of my outputs, or my y values, or my function value. And then the other one is going to be f of 2 plus h. So this is the formula that you saw in the previous video. This setup tells us that we're going to take the limit of a difference quotient, and by taking the limit of the difference quotient, we're going to find the actual slope of the tangent line, the actual instantaneous rate of change, the actual derivative value that we're looking for. Okay, so how do I do that? Well, I need to have a function. Now, we're using this one over here, so we're going to say f of x is x squared. So I'm going to take the limit as h approaches 0 of my input squared minus my other input squared, all divided by h. Why am I doing that? Because this says use the f rule, use the f function. If your input is 2 plus h, well then just substitute it in place of the variable. Well, that would be something squared. Or I can take this and substitute it into the variable, and that'd be something squared. Great. Now I can simplify this a little bit. By the way, if I try to take the limit at this point, I'm going to get a 0 in the denominator because I'm going to substitute 0 in place of h. And then in the numerator, if I substitute a 0 for h, that'll be 2 squared minus 2 squared. That's also 0. So I'm in an indeterminate form. I need to try something else. One thing that I'm going to try is to multiply this out. So if I multiply this out, that'll be 2 squared, which is 4, plus h squared, which is h squared, plus, don't forget, I need to multiply the inner and the outer terms, and that's going to give me 4h. So if you don't know where this came from, we can have a conversation later. But all of this is what you would get if you multiply 2 plus h times 2 plus h, which is what 2 plus h squared is. And then over here, 2 squared, that's 4. All of it divided by h. So at this point, I realize, I can subtract 4 minus 4 and cancel those 4's out. So therefore, the limit as h approaches 0, 4 minus 4 is 0, so I'm left with h squared plus 4h all over h. If I try to substitute the 0, I'm still getting an indeterminate form, so I got to keep going. And if I keep going, I can factor out an h from the numerator, and then I'm left with h plus 4 all divided over h. So think about where this h came from. I just undistributed or factored out an h. If I multiply h times h, I get h squared. H times 4, I get 4h, right? But why did I do that? Oh, because now I can reduce the h's. H divided by h is 1. And so therefore, I can take the limit as h approaches 0 of h plus 4. And if I do the direct substitution now, if I substitute a 0 in for h, I get my slope of the tangent line at x equals 2. This is not an approximation. This is not an estimate. This is the real deal. I found the slope of the tangent line at x equals 2. So I'm going to come over here, and I'm going to make a little note of that the derivative of f, the slope of the tangent line at f, at 2 is 4. So I'm going to zoom back in. Now, did you fit all of that in that little space? If you didn't, it's okay. If you needed more space, that's fine. If you needed the bottom part of the paper, that's fine. But I think it's important for us to kind of see how a derivative is, I guess, derived, but no, a derivative is found because the limit definition is the fundamental way of finding a derivative value. So in the next video, we'll do another one of these, and then we'll demonstrate that maybe there's a pattern.